and welcome to NOV Live. I'm Michael Gaines, host of the podcast NOV Today, and glad you're joining us as we kick off another conversation today on some really interesting technology here on NOV Live. Hope you are ready for some good conversation and an opportunity to ask your questions to our guest today. So for today's segment, we've got a special guest, Mr. Simon Eves, who is going to be joining us and talking about FRP technology and what NOV is doing in that space. Of course, we also have Asad Mohana, who is NOV's Director of Business Strategy, and he's going to be talking to us about recent happenings in the world of energy and things going on in that area. So we're going to be getting to those guys in just a second. But before we do, we are going to go to NOV's digital content specialist, Shelby Dumaine, who is going to tell us how you can be a part of today's show. Hey, Shelby, good to see you in the office.
Hey, Michael, it's good to be here. I'm back safely in the office doing the show for the first time from here. And what's really exciting, as always, about this being a live show, what we love so much about it is that we get to engage with our audience. So if you're watching this at home, whether you're on Facebook, LinkedIn, or YouTube, you can comment any questions you have for our guests or for anytime for Michael throughout the show. You can comment those below. I'm in the comment section throughout the show, reading as many as we can get to, and we're going to address as many questions as we can. So speaking of questions, that brings us to our next segment, which is Rig Geeks Post of the Week.
Rig Geeks Post of the Week.
All right, so this week's Rig Geek Post of the Week, we're talking about the Cocoon and Shroud, which is an impact protection system. This protects wellhead equipment on the seabed floor. We're going to hear a lot more about it later from Simon and from Michael. But our question is, how many tons does this equipment weigh in air? So with our question this week, we have a little bit of a surprise. We hinted to it in our post if you saw it earlier today. We will actually have a prize. So the first person who can correctly guess this question in the next 5 minutes, since we might be revealing the answer kind of throughout the show, but if you can guess the correct answer in the next 5 minutes, you will get a pair of NOV sunglasses and an NOV beanie. So we'll be looking at the comments, and the first person to comment that. Again, the question is, how many tons does this equipment weigh in air? For a tiebreaker, if we do have a ton of people writing in, then the secondary question will be, how many tons does this equipment weigh underwater when it's actually on the seabed? I look forward to seeing everybody's answers and hopefully picking a winner. So we'll see you at the end of the show for the results of Rig Geek Post of the Week.
All right, I don't have my pen and paper and calculator with me, so I'm excluding myself from answering, but look forward to getting those answers. Thanks, Shelby. All right, so as we just mentioned, we're talking with Simon Eves, and we're going to be talking about FRP and what NOV is doing in that space. So Simon, thank you for joining us and welcome to the program. Where are you actually joining us from today?
Well, good afternoon. I'm based in the UK at the moment. The sun is still shining, but we're, of course, a little bit ahead of you guys, so it's late afternoon here at the moment.
Sure. All right. Well, great. Well, thanks for joining us. And for those,
Thank you for having me on.
Simon is the Global Technical Director for Structural Composites here at NOV. So, Simon, for those that may not be familiar, I mentioned FRP at the just a moment ago. So I know there's some that say, please don't give me acronyms. Help me understand. So what is FRP, and what does that mean?
Yeah, our industry is as bad as any for acronyms. So FRP really stands for fiber reinforced polymer. Some people might know this material as GRP, which is the old term, glass reinforced plastic, but fiber reinforced polymer is really a much better generic term to use. And so these materials use reinforcement systems such as glass or carbons, maybe aramid materials. This is where the strength comes from. And these are mixed with a resin, a glue, if you like, that brings the composite mix together. And these can be things like epoxies or polyesters or vinyl esters. Combination of these makes this material. So at FGS, we use all types, but mostly for subsea, we're using glass and maybe vinyl ester, polyester resins.
Okay. And so I know that it's historically, the FRP has been seen as almost a very kind of specialist material Do you find that it's actually maybe not as exclusive as maybe it's perceived to be?
Yeah, I mean it's got some big advantages, which has led to uses over time. So weight is obviously a big advantage. Um, FRP structures are a lot lighter than conventional materials such as steel. So to do the same job as a steel alternative, an FRP solution, maybe about a third of the weight of steel. So this is a great photograph here. This is one of our engineering team in Plymouth holding one of our handrail products. If that was in steel, that would take a two-man lift, even if it could be done by two men. So weight's a big thing. And underwater, of course, this weight saving is hugely magnified, and we'll talk a little bit about that later on when we get to the cocoon. But the weight can halve underwater, so you can have a structure which maybe only weighs about a sixth of a steel equivalent. And another big advantage of the material is its corrosion resistance. This again is well known, but it's very resistant to corrosion. So where steel might rust, the FRP material is effectively inert. They're also very non-conductive, so can be good insulators against heat or good insulators against electrical conduction. So those are three big advantages. So yeah, that's led to a lot of uses. I think people might know it as a material used in the leisure industry. So you see it a lot in boat construction. You might see it in your mobile home or in swimming pools. But it's much, much more widely used than that. And it's probably not perceived as being such. But then you have Boeing making their Dreamliner, which uses huge amounts of composite, fiber reinforced composite material. The aerospace industry is one, but also wind turbine blades are made with fiber reinforced materials. Car manufacturers switching a lot now to composite materials for weight saving. So it's rapidly becoming a much more mainstream material, not necessarily just a specialist one.
So maybe kind of talking more to how you see fiberglass systems fitting today. How do you position fiberglass systems when you look at the market now?
Okay, well, NOV fiberglass systems has been in the marketplace now with FRP products for some time. And for those of you who know us, then the Bond Strand brand, for example, for our GRE piping is well known, well established. It's a global brand. It's used extensively in many oil and gas projects, both onshore and offshore, for the reasons that we said, maybe weight saving and so on. This is a typical photograph of a GRE glass reinforced epoxy pipe installed in an offshore oil and gas platform. Could be carrying seawater for fire deluge or something like that. So this is where we're traditionally known. But our markets have been expanding a lot. We're now moving into, for example, pressure vessels. So again, we're using the same technology in high performance composites to make pressure vessels, such as for reverse osmosis and so on. But lastly, as well, we're also moving into structural products. So the Bond Strand range is now taking us into topsides offshore, where we would be supplying gratings, handrails, ladders. These are to a good high fire performance specification, which is needed offshore in oil and gas, but also into subsea products. And this is a particularly exciting area. So this is taking us into things like protection covers for subsea manifolds. In this picture, you can see some node covers which are used on subsea manifolds to protect during installation phases. There's also our unique cocoon and shroud product we're going to talk a little bit about. And then also things like mud mats, which are used in soft ground areas where you want to prevent pipes or equipment sinking into soft ground subsea. So FRP's got a lot to play in all of these industries.
So for those that just joined us, we're talking with Mr. Simon Eves, who's the Global Technical Director for Structural Composites, and we're talking about FRP, fiber reinforced plastics, which is offerings that are coming from the NOV Fiberglass Systems group. So if you have questions on any of the conversation that we're having today, any questions on FRP, then we have your subject matter expert here today who's going to be taking questions from you in just a little bit. So feel free to put your comments in, whether you're watching on LinkedIn, Facebook, or YouTube, and we will be looking to get to those questions in just a little bit later in our conversation. So Simon, so one, thanks for the overview. It's helpful to kind of understand, one, how you're approaching the space, where this technology is being used, and also how NOV is approaching it. For today's conversation, we're kind of honing in and talking more in kind of in the subsea space. So can you give an example about maybe focused on where FRP is providing benefits, but maybe even more specifically, kind of in the CAPEX or capital expenditure and operating expenditure, OPEX space, because I know that's candidly probably
Absolutely.
top of mind for a lot of people.
Very much so, yeah. Just before we skip on to that, Michael, just we mentioned that sort of broad sweep of products, and for folks who are interested in that, we do have an interactive PDF, which is really visual and very simple in its explanation of the range of these products that we're doing. So I believe that Shelby's putting that link on for folks to see. If you're looking to have a look at that, then please just click on that link, and that will take you to that PDF.
Yeah, and we'll actually put that in the comments section as well, so folks have that.
Absolutely, great. So yeah, offshore. What's FRP bringing to the party? Because that's the bottom line. It's not just an exciting material, but it's got to bring some real benefits. And offshore subsea is no different. So big drivers here for offshore contractors and installers is weight. And so this is where CAPEX savings can come in with FRP. So let me explain the cocoon. This is an NOV product. We call it the cocoon and shroud, and it's a wellhead tree protection structure. So in shallower waters, particularly where you have wellheads installed like this, they're vulnerable to dropped objects from above, and also particularly vulnerable to fishing systems, which from fishing boats that are trawling in the area. So these structures need to be protected in some way. So in shallower water, traditionally what the customers would do is install some sort of steel protection structure. This would be a freestanding structure over the whole of the tree, and that is inordinately big and expensive to do. So the cocoon is quite an innovative alternative to this. It connects directly to the tree. It doesn't need independent foundations. It gets its strength and integrity from actually attaching itself to the flow base of the tree. And it primarily comprises of these two large doors. You saw those in the graphic. And here you can see actually a subsea video of the cocoon with some divers working on the installation of the cocoon. So these doors fully open and allow incredible access to the tree that's inside the inside the cocoon is actually protecting itself. So when these two doors are closed, they completely wrap around the wellhead and they're completely enclosing it, protecting it. These doors are pretty big. They're about 6 meters wide and about 5 meters tall. So you can imagine these doors in steel would be extraordinarily heavy. Each door in steel would weigh around about 4.5 tons in air. Now in FRP, each door weighs only 1.5 tons. So you can see straight away there's this massive saving in weight that's coming into play. But if you look at that weight subsea, because the density of fiberglass FRP is only around about 2, then that weight almost halves. The weight submerged for each half is only around about 0.75 of a ton. So this makes a structure which is, while it's large, is very safe and very easy to open. So operators can use perhaps smaller vessels, which are cheaper to use, or they can even use airbag systems, all of which are cheaper in cost. So from a CAPEX point of view, the cocoon is bringing in the advantage of being able to use smaller vessels for installation phase, as well as for operational opening phase. The innovation as well, and its docking also makes it a great CAPEX saving because it's very fast to install. Sorry, go ahead.
Yeah, no, I was just thinking as we were talking and looking at the animation and the video, for those that may not be as familiar with a lot of the subsea structures and operations, what you're showing there in that particular example is a really innovative way of protecting the assets that are being installed there. So for those that may have said, okay, well, I see that. What is kind of the maybe the historical or conventional challenges that those that have kind of had to own those assets and protecting them? What are some of the issues that have occurred in the past? Because it looks like the shroud by its design keeps foreign objects, maybe other artifacts from interfering or damaging the assets.
Absolutely, because any damage to a subsea equipment like that is really very serious from an environmental point of view, from a cost point of view, from a lost product point of view. That the list goes on. It's a high risk issue, and so if there is danger of dropped objects or fishing intervention which could damage some of these structures, then this is something that the operators pay close attention to. And traditional solutions are there in the form of steel structures, but the innovation of NOV's fiberglass products that can save money both in the deployment of these protection structures, but also the lower cost of intervention over the life of a structure. It's easier to move a fiberglass structure to gain access for intervention purposes. So really, this is where FRP is bringing in some innovations to save both CAPEX and OPEX costs as more and more production goes subsea.
So I know we've got several questions that are starting to build up in the Q&A section, and we're going to get to those in just one moment. I just want to ask you one more question before we get to other questions. So to me, and this is someone who really candidly has more of a downhole history than subsea, but even kind of coming into it, I can at least kind of see some of the advantages, even just in the visuals and conversation that we've had. So when you look at FRP and you talked to that earlier, maybe can you talk about some of the advantages that the FRP solution can provide, especially when you're looking at any particular subsea applications?
Yeah, a good example was our recent work with our CAPS company, Subsea Products, based in Norway, developing the Seabox product. Now, the Seabox product has been one that many of you may have seen before. Again, it's a great piece of NOV innovation. Subsea, this product takes seawater and it processes it through very electrolysis processes to purify it, really for direct well injection to an adjacent wellhead. So this saves having to manufacture such purified water from a distance and pumping it all the way to a remote injection point. So this is a fairly radical product. It's mostly developed now. It's going through proving processes before being launched. But we were privileged to be part of this project in being able to engineer and manufacture the control unit, which is a key part of this process. So this features the various anodes and cathodes involved in this electrolysis process. And of course, by nature of that electrolysis process, you want a non-conductive material. So this is where FRP was really a material of choice. It was probably a material of solution where conventional steel would have had a problem because of its conductivity. Making this kind of product in FRP was really a game changer in facilitating the successful development of the Seabox product.
No, that's great. So we want to maybe provide some questions for you, Simon, on today's topic from some of today's viewers. So to do that, we're going to go ahead and bring Shelby Dumaine in to start getting some of those questions answered. So hey, Shelby.
Hey, Michael. So we have this first question. Does FRP have any environmental benefits subsea or when comparing to steel as far as carbon footprint is concerned?
Yes, absolutely, because there's lower carbon footprint associated with FRP structures. Looking at it in different ways, whether it's in construction or whether it's in whole life costs and energy that takes to look after or repair or maintain a structure. So it depends where FRP is being used and the context it's being used. But yes, FRP is definitely a material of the future in reducing our carbon footprint.
Mm-hmm. Yeah. So then this next question comes from Garima on LinkedIn. She was wondering, what are some threats to watch out for with this product?
Okay, so while the FRP material is inert in subsea, that it will react in some respects by um, absorbing a little bit of water. From a structural point of view, that's something that we just need to be concerned about. But we have been doing a lot of testing and research in that. We have information and data that allows us to predict safe working lives of FRP structures subsea. So rather than seeing that as a threat, I guess it's something we understand and we can build in. So it gives our customers real confidence of the full life performance of these FRP products subsea.
Mm-hmm. Great. So then we have this one from Michelle, and of course, you know, we're not going to talk about specific costs. That would need to be more of a conversation. But she was wondering if you could talk a little bit more about cost when compared to steel.
Okay, so FRP materials tend to be a little bit more expensive than steel, although that depends on perhaps how many structures you're making. FRP can be really cost effective if you're looking at multiples of a common component, for example, because you can share tooling costs. But I think the key thing to think about with cost is not so much just what it costs you to make, but actually what it's costing to perhaps install a product. So we spoke of the cocoon and the cost savings associated with its installation. So those cost savings in smaller vessels could actually completely outweigh any additional cost that the FRP structure might take to build. And that's before you even begin to think about OPEX cost savings that we also discussed. So we do a lot of work in what we call value proposition in our projects with our customers. So we're looking not just at the cost of the design and the building of a product, but actually what the real cost for installation and the real lifetime costs can be. And those can sometimes be surprisingly good for FRP as you dig into those numbers. So again, we'd be delighted to talk with folks on more specific projects to share that data that we have.
Mm-hmm. Great. So this question is coming from David on Facebook. He's wondering if there are any non-oil field applications.
Yes, we have a whole side of the business that looks at non-oil fields. So into civil market applications, we've been known for building footbridges, and there's so many different developments going on. I think the key thing at the moment is to keep a focus and develop some really good products for specific applications. But there's a lot happening within FGS, and we're looking at ways at how we can perhaps take some of the technologies that we've developed into other markets. So as an example, we spoke briefly about our fire technology, where we use FRP on topside applications. So our thinking now is, well, how can we take that into more construction, perhaps mass transit applications where similar fire performance and so on would be required? So yeah, we're excited. We think there's lots to do.
Mm-hmm. Yeah, that's definitely exciting. We love hearing about all the different applications. So this next question is coming from Shankar on LinkedIn. He's wondering, what is the depth of operation for this?
Okay, so for the cocoon, the cocoons we have are mostly installed in the UK North Sea, which is around about 100 meters in depth. There's possible applications in a little bit deeper water out west of Shetland in the UK waters. That's down to about 400 meters in depth. But in terms of other subsea structures, there's really not an issue in terms of the depth that we can take FRP down to. These are solid laminates. We're not coring these, so they can take the various pressures that go on. And so in terms of protection structures and other applications, you know, we can go down to much deeper depths.
Mm-hmm. Gotcha. So we have this next one from Destiny on, it looks like LinkedIn. Is there a code that can be specifically set for the deep sea and oil well features?
Yes. Okay, so there's obviously codes which will set out performance requirements for a different subsea structure for whatever they're made from. So for example, a protection structure will have to meet some level of energy impact absorption, and that they're driven by, for example, a NORSOC code U001. So those are kind of performance specification codes. But there's also a really good FRP design code generated by DNV. It's DNV C501, which sets out parameters for designing FRP structures, whether they're for topsides or subsea. But it's a really good code which controls the FRP design. And it's one that gives, again, operators good comfort. We design to that code as standard. It's a big document, but it's comprehensive and it's sound.
So it sounds like some really good questions, and thanks for those that are watching for providing those really great insight, Simon. So as
Absolutely.
you look to kind of towards the horizon and the future of fiberglass systems, and specifically on the subsea side, what are things that that we're focusing on that folks can be on the lookout for?
Okay. Well, we're seeing the subsea side growing and exciting. There is no doubt that in the future, more and more of the offshore kit is going to go subsea, and we're seeing those drives coming from all over the world, from globally. One of the most exciting projects we're working on at the moment, and again, we're privileged to be part of this with our sister CAPS companies based out in Norway, is the scheme of putting unmanned product storage systems subsea. Now, this is an incredible concept. Rather than having a floating storage vessel, which is traditionally the way, this concept takes the product storage subsea, and it's a low CO2 solution for this kind of requirement. This is going to take us into a different realm of fiberglass structures. These will be some of the largest FRP tanks ever built. And there will be a series of these in a steel frame holding a product subsea. So we're working, supporting our sister companies as they're bidding for the support, for the backing to be able to bring this product forward into reality. And yeah, we're excited to be part of that.
That's great. So I know we're starting to wrap up here. It looks like we might have one more question that might be a great segue into some of the resources that we have for folks. Shelby? Oh, I think we have you on mute.
Can you hear me?
There you go.
All right. And is this the question? I just want to make sure.
Yeah.
All right, great. So this is from James on LinkedIn, and he's wondering, how does your handrail system compare to steel or aluminum handrails?
Again, it brings forward the advantages that we spoke of earlier. So people have traditionally used steel for many years. It's the product of choice. It's what's there, but it's not great for offshore because it's heavy and because it rusts. So if you switch across to an FRP handrail, you're going to save a whole lot of weight. You're going to save a whole lot of maintenance costs. And weight, for example, could be safely used in additional production equipment. So it's not just saving a dead weight. You can use that weight in other productive ways and generate more revenue. So whether it's handrails, whether it's grating, whether it's structures, these FRP products can bring some real benefits into your offshore operation. One of the things that I meant to say in the earlier part of the discussion, Michael, was we've talked a lot about products, but within our company, we've got some great engineers. We've got some real innovation going on. We're developing new ideas all the time, and what we're making available within the NOV family is that capability. So if people are looking at ideas and thinking about how they can bring innovation into their products, we'd be delighted to hear from you. We kind of set ourselves up with an advanced design and advanced manufacturing, what we call ADAM, and you might hear that see it in the brochure. But it's there as a powerful part of who we are, and we want to be able to use our knowledge base to expand and develop different products for the company.
Great, man. I know that, like we said, we'll make sure that we put we'll put the link for the interactive PDF in this post. I think we put it in the comments as well. But yeah, it's already in the comment section. But yeah, definitely a good read there and a way to understand more about the benefits that we've been talking about. So yeah, I think the idea of advanced design, advanced materials, that sums it up for me, especially when we're talking about composites. So I've been speaking with Simon Eaves, the Global Technical Director for Structural Composites here at NOV, and we've been talking about FRP, or fiber reinforced polymer. So Simon, thanks so much for talking with us. If you have questions for Simon that we didn't get to today, you can reach him, and his email is there on the screen, simon.eaves, that's EVES, @NOV.com. So Simon, thanks for the conversation today.
You're welcome. Thank you for the opportunity.
So we're now going to go ahead and move into our next segment, which is our segment we call Ask Assad. So Saad Mahana is the Director of Business Strategy at NOV, and it's a guy that we go to for all things market strategy and other insights. So Saad, thanks for joining us today.
Great to be here, Michael.
So I know that there's been a lot of activity in recent days, certainly in recent weeks. So more specifically, it looks like oil has gotten back into the $30 range. So wanted to see if you could give us a quick understanding as to what's going on in that space.
It's amazing, isn't it? With the fluctuation and volatility we've seen in the last few weeks. That's right, Michael. WTI, which is the US benchmark, was last trading at $32 per barrel, having gained over 70% this month alone. While Brent crude futures, which is the global benchmark, have traded north of $35 per barrel, or 39% in the monthly rise. If we look back at what kind of happened in the last few months, at the trough, and before I speak to the slide, at the trough we saw about 35 million barrels of oil in excess supply in the market, while production cuts coming from OPEC Plus in the month of May, about 9.7 million barrels there, in addition to about 3 million barrels coming from jointly between Canada and the US, kind of stabilized and drove market in the right direction. We also saw information about the mobility on the streets from the US and other places. And I'd like to pull up that slide now to talk a little bit about what Rystad's been tracking. And this first one's about road traffic. If anybody's been on roads lately, you'll notice that traffic's not something that you're going to have to face. And that's because we've dipped quite a bit in the month of April from the highs of earlier this year. You'll see that the Far East or Asia started picking up ahead of the West or Europe or the Americas because the East saw the pandemic effect earlier on, start opening up ahead of us, while the US kind of start taking these measures later. The expectation going forward is for that trend to keep going in that direction, which is really what's needed to increase consumption. Remember, this is all about consuming. This is all about demand to match the reduced supply that we have in the market today. Moving on to the next slide there, Michael, and I want to talk about what's going on in the air. We saw in the last month about 70% of the flights being grounded, which is humongous if you think about the number of airplanes that weren't needed to transport people because of the lockdowns. So I would say, looking at the graph, if we look at what happened in 2017, 18, and 19, the expectation for 2019 is to exceed that, and really north of 120,000 flight a month. But from what we've experienced in grounded airplanes, that dipped by over 70%, 74, 75%. What Rystad describes as two scenarios: the effective prevention scenario, where there's strict, effective social distancing measures that are being implemented, really suppressing the outbreak at an early stage. And the other scenario is the mitigation scenario, which is more of a looser social distancing measure that's implemented. Still enough to slow down the infection, but still kind of leaves room for a bit of resurgence. So we could see from now till the end of the year, in both scenarios, increase to the in number of flights in the air. Not quite where we'd hope them to be, but certainly in a more healthier space to compare with the current supply.
Mm-hmm. So then, if we're looking at road traffic, somewhat slightly increasing, like you said, changes in Asia happening before other regions. But, if we're seeing that uptick, hopefully seeing some inflection in air travel, then it kind of begs the question, at least from my mind, does that mean that we're kind of getting back into at least I don't know if safe zone's the right word, but at least a better position than in days past?
Right. I mean, it's certainly a good indication. Prices are still extremely depressed compared to what we've seen. Remember, Brent traded at $69 earlier in the year, down to the 30s today. It feels like we're in the 70s, but we're still in the 30s. But it's clear that the process of rebalancing supply and demand is underway. It's working. There are still some worries that maybe that increase has been too swift. Remember, only less than 4 weeks ago, we were in $40 negative. So that could cause some damage down the line. The production cuts that we talked about, those definitely help. The storage availability in Cushing, Oklahoma, where the physical delivery of oil happens, freeing up some of that storage does help. Increased demand from what we just talked about on the road and in the sky. All those are fundamentals to get that price of oil to go up. But the concern is, could this be a to prove self-defeating process? Will oil producers now go and say, yeah, you know what, at $30 I'm profitable, let me pick back up and start drilling again? So unless there's some sort of new type of capital discipline, and last time we spoke, Michael, we talked about a way of optimizing or an optimized pace of development. And that's what we really need, a new culture, a new way of addressing development. Unless that happens, we could still be in trouble. So I would say we're not entirely out, by no means, of the depression. I would just say that we're seeing some recovery. That's based on fundamentals, and that's not emotions. So there's market efficiency there, and it's going to depend on how the cities are going to reopen and how we're going to be abiding by the regulations for social distancing.
Well, definitely looking forward to increased good news as this recovery continues. So yeah, I know those automatic lights are great. they're great when they're great, but in any case, all right. Well, thanks. I
do want to mention just one thing. Expect a great talk with our VP of Offshore Rig Technologies.
That's right.
Coming up at Graham Day on the next Ask Assad show. We're going to be talking about what's happening offshore, and believe it or not, there's a lot happening out there. So stay tuned for that episode.
Yeah, that'll be great. Yeah, so that episode will be coming out probably early next week. So yeah. Great. All right. Well, been speaking with Assad Mahana, Director of Business Strategy at NOV. Thanks so much, Assad.
Thank you.
All right. So thanks for tuning in. We're now going to go back to Shelby Dumaine to get the winner of our Rig Geeks Post of the Week questions. So for those that we want a quick refresher, what was the question, Shelby?
Thanks, Michael. So the question I asked about the cocoon and shroud, I asked how many tons it weighs in air, and then the tiebreaker was how many tons is it underwater. So luckily we don't need to go to the tiebreaker. Looking at, there were a lot of really great guesses. I did want to reveal the answer now. So the answer in air, it is 1.5 tons, and in subsea, it is 0.75 tons. And I'll show you now. We have the winner right here. So we will contact you. He put it in pounds, but I did the conversions, did some quick math, and he was the closest to getting that answer. So we will contact you to get you your NOV beanie and NOV sunglasses. So hot or cold temperatures, we got you covered.
All right, great. Well, thanks everyone for participating, and thanks for joining us here on NOV Live. Look forward to joining you again next week, right here at 11 o'clock Central, as we talk technology, innovation, and have subject matter experts to take your live questions. So from all of us here at NOV, thanks for watching and thanks for listening, and we'll talk to you later.